Okay, so how much does it weigh? Approximately what does it weigh?
100 newtons.
About 100 newtons, right. So would you agree that I've just done some work on it?
Yes.
Okay. And if I lifted it 1 meter, how much work have I done on it?
900 joules.
100 joules. I applied a force of 100 newtons, 1 meter. It's got 100 joules of energy. What kind of energy? Gravitational potential energy. Now, would you agree if I lifted up 1 meter this way or 1 meter this way, it has the same energy?
Yeah.
Because it's still the same distance off the ground as it was before. So now, if I were to let it go, then it would start to drop. And when it gets down to where it's only half as high off the ground, how much energy will it have?
1/4.
50 joules. Okay? 0.5 meters. So it would have 50 joules of potential energy. But the law of conservation of energy says you can't lose energy. So where did the other 50 go?
The air.
Kinetic. It's going to be moving. Now, it's going to continue to pick up speed as it goes down to its lowest point because it's losing more and more potential energy, and that has to go somewhere. Now, at its lowest point, it has 0 GPE. I just said something, and you took it. I took it for granted, and you didn't ask about it. Isn't the ground 0? It doesn't matter where you define GPE to be 0. It's totally arbitrary. So I'm defining that as 0 GPE. Now that 100 joules that you calculated of GPE, it's all gone. So it's all KE. That's why it's going the fastest it's ever going to go, because it's got the most of it. It's got all of its energy in kinetic energy. But it's going to keep sailing, right? It's going to pass right through that. And because it's constrained by this cord, it's going to gain GPE. What does that do to the KE? Yeah, it reduces it. Now, eventually, it'll lose so much kinetic energy that it stops. How high is it now?
Not quite as high.
Almost a meter.
It'll be 1 meter high because it'll have traded all that KE back into GPE. So this is where I need Annika to be my volunteer. Annika, did you notice that there's a little patch on this? Okay, lower here.
I'll do it. I would be able to stand there.
Put your neck out like this. Yeah, just like that, yeah.
Okay.
I'll hold it. Are you nervous?
A little bit.
Oh, let's come over this way. Come forward, Russ. Ready? Now, she has nothing to worry about, right? Right. So if you go any higher, in fact,
How about the wind? How about the wind?
in fact, there's a little friction, so it probably won't even go as high. Reverse friction. Reverse friction. How's that?
It's fine.
Okay, we're not done. Okay, so this time we're going to do it again. And what I'm going to do is, instead of just releasing it from rest, I'm going to give it a little push so that I add about 10 joules of potential energy. Ready?
Okay.
Trust me? Down low. Okay, so what I did is, in addition to the 100 joules of potential energy, I added some energy. Let's say I added 10 joules. So now it's got 110 joules of energy. How high can it rise? 1.1 meter. And if that had happened, and I didn't push her out of the way, we would have converted some of that energy to heat. Heat is kind of a catch-all category that includes broken jaws.